In this video, I'll show you how to construct a receiver operating characteristic curve to evaluate the efficacy of a binary outcome model. To start, I'm going to open a document that contains a binary outcome as well as some explanatory variables. This is a fairly simple document with only 4 columns. One is a binary admission column, which contains whether a student was admitted to college, their GRE score, the GPA, and their class rank on a scale of 1 to 4. Here, I'm going to treat the rank as a category variable. Now I'm ready to construct my model. I select Admit on the left, and then check boxes for GRE, GPA, and rank on the right. Now I have a model. It looks like a number of these variables are statistically significant, but that's not necessarily my interest right now. By default, the model view displays the residuals on the left plotted against a variable of interest. To get an ROC curve, or receiver operating characteristic curve, I click the ROC Curve button. A receiver operating characteristic curve is a visualization of the sensitivity versus the specificity, that is, the type 1 error versus the type 2 error for different cutoff values. If the area under the curve is close to 0.5, that means that the model does not have very good predictive power. It is essentially the same as choosing at random whether someone is admitted or not admitted. If, on the other hand, the area under the curve is closer to 1, and this line comes close to the top left corner of the box, that means we have a model with very good predictive power. I can see how the ROC curve changes in response to including or excluding different variables in the model. For example, if I take GRE out of the model, the area under the curve, which is written at the bottom underneath the ROC curve, is currently 0.6928. If I uncheck GRE, it goes down to 0.6801. Including a variable will only increase the area under the curve. For a more dramatic effect, I can take out the school rank from the model. You can see visually there's a pretty big change in the predictive power of the model, especially around here and around here. In addition, the total area under the curve, which has a maximum value of 1, goes down to 0.6186. Finally, I can export data from the ROC curve by control-clicking it. I have a number of options either to export the image or to export the underlying data. For now, I'm going to copy this data to the clipboard. This allows me to paste the data in another program such as Excel or Numbers. I can also see the actual cutoff values associated with different specificity and sensitivity values. That's about all there is to do with ROC curves. If you have any questions about this, please leave a comment. If you enjoyed this video, hit the like button. Thanks for watching.